Good day. In this video, I'm going to show you how to establish a link between Codesys and Ciros education. And first thing first you need to do is to open your Codesys, and you can also open your Ciros education while you add to that. Okay. Okay. Next up, you then Ciros Codesys is here. You click on new project and rename it in the best possible way you can locate it, and say for instance let's just rather create a folder nicely. Let's do this. So around here you just insert new folder, and then you say maybe work on project one. Let's say project one. If you want, you can write your name and surname, and let's say surname, actually surname, and your student ID. Avoid long file names and click OK. And then you can also write your student ID here also, ID, and also your surname. All right. Then after that, you create. Okay, seems like what happened? Okay, it's fine. I'll try to locate it. So it is very important to be able to locate also where your work is. You can just try and look for it. Okay, we are also using double screen to record. So let's look for it. So name and student, this one's the old one. Let's see for the one that I just created now under documents, and you need to go to Codesys, and this is the one. Okay, so I think it went under the new folder, which is fine. It's fine. You can always move it up when you are done, because I want all the files inside that to be safe also. Okay, so now select IO link master, select the relevant language you want to use, and then this one we are using the CECCLK. All right, then click OK, and then after that you wait for it to load. And for this exercise I need you to close this onboard IO links. So we're going to not use this onboard. We're going to use the IO link master here. So what you need to do is to come and right click here and add plug a device, and under the IoT 101 you click on the BNI, and then you plug your device. All right, and then you click close, and then you come to another one. You can even copy and paste if you don't mind. You can copy and paste like that. Okay. All right. And then from here, you also can rename this according to the machines that you are attempting to control. The first one, they're going alphabetical order. The first machine comes first, and the second one come next. All right. So now from here, let's do the system configuration. We'll go to symbol configuration, and then we click on add. Okay, after adding this we then go to build, and then after build we go to, you click on both of this, and you click on settings, and you go to enable direct IO access. It's very important. It is the one that enables you to 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 get a communication between the PLC and the IO link. Okay, then under the IOs I want you to 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 go under, you double click on these two, and then you go to both of them. You see these are tabs now. These are tabs. everything now becomes a tab. So under the IO link mapping, I need you to change the settings there to be enabled to always. And then after that, I want you to go to the other one to do the very same settings, enabled all to always. Okay. And then from there, I want you to go to simulation under online, and then simulation, go back to online and go to login. Then after login, click yes, and there must never be errors. No errors is a good sign. Then you click on start. Right, so this is the first BNI. These are your inputs and these are your outputs. Okay. Then now let's establish the very same thing that we are trying to link between the two softwares now here. Let's establish the link now. You're gonna go to new here. I don't recommend you clicking like that. Rather click on the drop down and click on the MPS system and then rename it, and maybe say name and like your name and student ID. Preferably say name and student ID. Okay, and then yep, and then you save. All right, perfect. Then it's gonna come like this. Okay, and then you gonna go to Festo MPS, and then we have the buffer there, we have the distributing adjust, we have the standard distributing, we have the conveyor. Right, so now if you can pick up now the between the two, we have a six slightly different machines here. If you look at this one is written first on top here, and then this one it's just it has a DIN rail on it. So these ones with the DIN rail are compatible to work with each other, and then the ones that are written to Festo, they are also compatible to work with each other. So we're going to take first the distributing conveyor, you add it like that, right? Then after that you're gonna go to picking and place station. I think it's somewhere here under P, this one, picking and place. You also click on it. So if you observe carefully, you will see that the machines have merged. If let me just zoom. If you come here, you'll see you can then turn. If you come here, then you see you can drag up. If you scroll in, scroll forward, scroll backward, this is what you're gonna get. All right. Then if you then press also control after running the machine, maybe clicking on these two items, you can then now be able to utilize them from the shift and the control button. So the shift does this and then the control does this. So it has merged two machines actually, but in real essence they're not supposed to have been merged. As you can see, it's a really messy situation. So to separate them now, you go to edit mode, and you can see now on edit mode, when you select the machine that you want to move, you can simply move it to wherever you want it to go. All right, so now if you're not happy with the angle, come out of the edit mode and put it on a suitable angle. Okay, I can see it's very high. Right, so I will just put it like this, on this angle, the upright angle, and bring it also to closer by. All right, and then go back to edit mode, and click on the machine you want to move. And as soon as it gets close to these dots, it needs to connect. Right, let's see on the height perspective, because I can see that I mistakenly changed the height. And then let's try and see if we can change the height. We can. You see now. Now they are connected. Now they are seemingly connected to each other. Perfect. This is what we want now. We have two stations now. All right. So now let's now really start to create the link between the two. So how do we do that? We go to modeling, model explorer, and go to objects, and then go to the first one, which is the distributing conveyor station. Click on it, and as soon as you click on it, you're going to see that there is another section that comes up that enables you to go to the PLC. So this is how we go to the PLC. Right click and go to properties, and when we are here on properties, you are now able to select uh, 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 the type of PLC you want to do now. If you're using S7 simulators, S7 simulator will eventually connect. And in this case, we want to use the OPC now. So with OPC, you can click on OPC. You see that we have details here of the OPC. We have the local host, we have first dot identic dot ezopc or ezopc.2. This is how it should look like. And if it happens that you don't find it, you can refresh, and then you can see that there are a variety of OPCs that you can find. This one we are using the dot two. If it came by default, please don't change it, okay? And then when it comes to this side now, the most interesting side of this PLC, you also can close there some windows there, as you can see now, so that we can get a much more larger space. Okay, so we have the we have the inputs and their addresses here. So now we are connecting via the visual PLC. Ne? So we want to change these addresses. So what we can do for now is we would click on the first address and scroll down to the last one. Don't click before. Click on the first one, scroll to the last one, click Shift and hold shift and click simultaneously now to get them highlighted, all of them. And once you right click on top, you can remove all these items. So now we need to reconfigure them. All right, so how do we then reconfigure them? We reconfigure them to by saying connect. You see now something come up now. We are currently connected via the visual PLC. Now we want to consider the codices. Now we're gonna go under the bits or the addresses used on codices. So now, if say I want to then establish the link on this system or on this machine, so first. First of all, what you need to understand is that uh, normally outputs are not briefly defined compared to inputs. Inputs are there, you can easily find them. So now I'm minimizing my window because I want to call up for something else. So if you come here to show show the IO monitor. So now this helps you to see which inputs are open. So now we are having I1 until I7 there. And then if you come here, these are actually the inputs that are there on the machine. So these inputs are well described. You can tell that in the beginning of the conveyor. So in the beginning of the conveyor is your GB1, BG1. All right, let's go and confirm that on the beginning of the conveyor. You then zoom. You shift with a shift button. Then you turn now for a suitable angle. Then you come to this one. GB G1 BG1, and now I am going to call that one. You see that there's a similarity there. This is the same, so it's easy to really locate the positions of the machine. From there, all you need to do is to assign the inputs, but I can also start with it and later on show you how we supposed to assign the other stuff. And also once we move to the other PLC, you come to here and change this to be focused on the PLC, on the pick and place machine. So now we will see everything from a point of view of the pick and place. So now we now on distributing, as you know. So now the first one, this one, we know it's located there. Okay, so let's go to our this then that one there, the BG is actually the I input is 0 basically. So now how do we then make sure that we put the right bait on it? Okay, we're going to compare now with these inputs here of the BNI one, the first BNI. And it is very important to also remember that you are allowed to retype, rename these BNIs. So if you come here and okay, maybe let's just see if I can't. Okay, you see now you can rename them. So this one is the distributing. You see, distributing. Right, enter. Okay, what is wrong? Okay, all right. So I log out and now start typing. Mm, I don't want to do funny things. Yes, like this. Distribution. So this is distribution station. Yeah, it doesn't matter. You can just leave it like this as distribution, and then this one as your the pick and place. Pick, pay. Sorry, not pink. Pick and place like that. All right, enter. All right, looks like it doesn't like us to. Let's see. Pick. It's either it doesn't accept symbols or something. Let's see now. All right, it looks like it doesn't like the symbols. So whoops, okay, just right. No, no, no. Okay, uh, okay. Let me try. Pick underscore place. Let's see. No, it's actually searching. I don't want it to search. I want to edit this one. Yeah, like that. Pick underscore place. Somebody did showed me this yesterday. I never thought that it wouldn't accept the symbols. So now the first one is distribution, the second one is for pick and place. Now we are on the first one, which is the distribution. So we want to see now the inputs involved for this distribution. All right. Okay, now we are back and we still don't have errors. Remember, errors are a bad sign for your work. So then we've deleted this. So say accept. Ne? All right. Secondly, now I want to see where are these inputs that we are talking about. Where are these inputs? Make sure also you are working with the right value. So now, according to what I know up to by far, uh, right, all right, no, no, okay. These in the inputs they don't matter as yet. We haven't yet established real connection. So the first inputs are positioned in such a way that they match exactly what is in your PLC. We have the first inputs here, the first seven inputs, and if you remember very well that I said that These ones are also 7. 1, 2, 3, 4, 5, 6, 7. You see, they are 7 also. So these are all the inputs that are there. So now we need to be able to assign them properly. So we can also, while we actually we don't really need any difficult configuration because we know where they are and we can always locate them. So what we can do now is to actually put them the under our notepad, under our notepad, okay, like this. So but the address, they will be using this address, the 2.0. So but before we do that, I will have to show you something. Let me just quickly assign, because I see that I'm making a mistake. Let me just assign some items here so that we can really have connect control over them. So now they are on bit 2.0 or address 2.0. So we're going to come here. This is 0.0, as you can see. So we're going to go to 2 now. We're going to 2, and then there is A and there is E. A is output, E is input. So this first one here, it's going to come there. And you're gonna go to 1 now. You can always skip. Actually, it's not a must for you to always match these things. Like let me just indicate for you. Let me delete this. uh, okay, you don't delete, you remove. You right click and remove. Say for instance, I want my inputs here only. My inputs are is, okay. So this one here, you can say click on it, the 2-bit 00. As you can see there, it's my first one. Then second one is there. You are selecting only the gray. Look at this, you select only the gray, select only the gray, and only the gray until the 7. From the seventh one, we're starting something else. As you can see, we are going to the 3-bit, the EB 3-bit. So now with these ones, now you can then come and just establish them there. So now you have all your bits for, you have now all your bits for what you call this, for your inputs, okay. And then with this said, you can also establish for the bits for the panel now, the start and the stop button. So this is the start button, this is for the stop button. So how do we then establish that? We can come here and probably use 3. You see here, we can use the first 2, the 3, these 2. Let's use these 2. So you see we've counted until 7. Now we're starting from 0. So we need ix 0 now, 3.0. So let's go to 3. Actually it's this one, 0 and 1. So it's gray 0 and 1. This is the one, like this. And we then position them here. This is my start and stop button basically. So they are now well configured. All right. So now what next up? What we need to do now? We need to at least come up with these items. Now we're going to say for distributor, inputs for distributor, or maybe the panel. Let's start with the panel. This this is for pardoning its values. So once you don't want the program to read them, you say forward slash twice, and then it won't read it. And then this is for the panel. Okay, panel inputs actually. Yeah, right. Panel inputs like this. Then now your start button, it's a we can just say PB or PS for argument's sake. PS at, and you take now this address here, I don't know how to copy it, but yeah, you take that address at which is percent and I x 3.0. Okay, and then after you do this colon, then you write bool, and you do the semicolon. All right, and then you do this, you pardon, and then you say this is my start. Basically, this is for your comment, your start push button, PB start. You can just say PB start to match up with the abbreviation there. All right. Then now we do the same. Others can just say P0. You see now, now we're having the stop, so we are facing challenges. So rather say P0 and P1 for argument's sake, and then here we are having a 1, and then here we are having a stop, something like this. I am not sure if you can write the full number or what, but like this, I think it's fairly straightforward. You can see the whole configuration much nicer. Okay, and then you say this. You can almost copy everything. You don't really need to retype everything from scratch. So these are the distributor inputs. Distribution inputs. All right. So distribution inputs, they're going to be the sensors, ne? Sense S1, like this. They are named in its form, and they are for 2.0 and 2.1, like this. And then obviously now we are actually now copying the the information over here. Let's do this. The information over here. Uh, So now your S0, this is your beginning of your PLC. Uh, I normally like to say S1, sensor 1. This, okay, now I need to separate the two. Let me maybe apply and I want to separate the two. I don't know why they are now married to each other, but let me separate the two like this, right? This is my S1, and then this is my S2, then this is my S3. You see, like by sequence, they are actually following each other. And this one, it's a normally closed, as you can see. Uh, the GB1, BG3, it's a normally closed, so you need to also indicate that. So that's my position. These are actually positions, but I normally describe them like this. This is my sensor 2, or let's just say point A, all right, and point B, like this. Then that's your S1, okay, and to make your life easy, point A, the a better description, it will be like this. Point B, you need to always come up with a system that works for you, a system that works for you, right? And point C, you see that, point C, and 2.2, and that's it, right? So we're going to actually preferably skip this one. uh, PLC input. I normally don't know where it is. Like with my experience, input. Input. Where are you? Oh, this thing advanced. Okay, it does even tell you what when you click, but it doesn't really indicate with their locations on the system, which is not a transmesh. Also, uh, I hoped it was gonna do that, but it's fine. Let's then now on. So what is happening is the following one, it's undefined, so we're not using it. So this one, maybe you're gonna say This is just say X for undefined, for argument's sake, so that you don't make any mistake. Then you're gonna say point undefined. Or not applicable. Yes, not applicable, like this point not applicable, or not applicable. The reason why it must always be there, so that you don't make a mistake when you're doing, because it's there on the wiring diagram. So it's very important for you to always include it, and so that when you skip it, you know that you don't really skip it by your own doing. You know, you skip it knowing what you're doing. So now, so this is a sensor when the cylinder is retracted, which is this sensor here. You see it's C1 BG1, the cylinder retracted here. The sensor that indicates that the cylinder is done what is retracted. So cylinder retracted, you can just say uh, so this one will be maybe your C1 cylinder retracted, CR cylinder retracted. All right, and then you come write it in full here, cylinder retracted. So this is a sensor that tells you what is happening on that cylinder. All right, and then now do not forget the file, the address writing. It's very imperative to always remember them. Right now we have the 2.5, and then the cylinder probably extended. Yeah, extended, as you can see there, cylinder extended like this. Right, and then the last one is just to say the magazine is empty. So I believe, and also this one is activated, the cylinder is there, is here, the cylinder rod. This is a sensor, actually this is a sensor, uh, 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 this is a sensor that is picking up the signal here. This is the actual sensor that does that. So that's the one that tells us that the cylinder is retracted. And another sensor here, and it's head. Yeah, that's how. Yeah, this is a sensor, actually. They were supposed to have done it with a different color for much more presentation. I will cover, I believe I've covered this under my class for electropneumatics, but I can always do another video too for a clear description of that. So now remember, this one was retracted, this one is advanced, advanced, right, and then we copy again, and then we paste. Here's just to say magazine empty, magazine empty, right, and that's your 6 then, right, and then just, and then you write it in full, magazine empty, make oops, uh, let's just say empty, like this, m empty. Empty, like that, right? So now this is fine for now. These are the inputs for the distribution system, and now we don't know how they are assigned on the outputs of the distribution system. So we can just copy this first one, and then you say enter and paste, and enter again, and this one you're gonna say outputs. So whatever that is here, it's going to be your conveyor, which is CB, the conveyor belt, and this one is going to be your, it's an assumption, because we still need to test. This one is going, and then the address might change, and then maybe you might say here CB forward. So I'm just showing you how it will look like, but nothing is yet defined, because we still need to test all these things. So we can't just conclude, and we didn't assign them. We didn't assign the outputs. Let's close this for now. Uh, let's. I want to test something. Let me test something on the distribution. I want to test something. Play. Uh, right, I'm having an error connected. There's that one, the virtual controller. I wonder what is the error about. Okay, all right. I can't establish the reason for error for now, but I need to see if whether I can get a response over the bit this we are on inputs, isn't it? Right, I want to see if there is a response on there's these ones. Yeah, the 0, the 30. Let's see. Yes, there is a response. You see that there is a response. Bravo, bravo, and the others. Yeah, this is working perfectly. This is number one. This is what we need. So, and let's see here. And there's that one, that one. This is normally closed. Remember that and describe it properly on your notebook. Normally closed, it means that you must write it as a normally open when you are programming it later on. Normally closed like this. Yep, this is becoming a lot now. All right, then let's now uh, let's now check the outputs now. Let's check the outputs. The outputs even here, they're not properly described. As you can see, we wish that they were describing everything that is happening here, but they don't, unfortunately. So, which is not a train smash. Which is not a train smash. Let me see something that I saw yesterday. I saw somebody doing this. Conveyor forward GM1, and I click on it. Where's the GM1? Alright, this GM1. Workpiece at the end of the conveyor. What is this output? No, this is not clear, honestly. Like, I don't know how that guy was doing this, but it's fine. Let me do it my own way. We're gonna go to modeling and we're gonna go to model explorer. Alright, and we're still on the distributing. You right click and go to properties. Right, properties is there now. It's hitting itself. Okay, whoops, the perfect. Okay, so now we are at OPC items there. Our interest now is to establish. No, no, no. What are you doing? Hey, 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 don't do that. Uh, right. So now you're going to find them like this, and where's my general pose dimension? What happened? Ah, come on, dude. You're not showing me what I want. Oh, I only here. Apologies for that. All right. The things that I press unknowingly, like, ish, what am I doing? Model Explorer, this, come, where are my objects? Okay, and then this, like this. Delete this one. Leave it on OPC, please. This is my OPC items. Yes, like this. Right, and then now we will put outputs now on here before we can test them. So let's test the outputs. The outputs are under outputs. Okay, we're gonna go to outputs, and the outputs that we are using are these outputs from here. It's a very complicated PLC world that I really can't really tell what is happening. I can't really define it. So what you must know that we are using the second pin. On inputs, we are using the first pins. So here we are using the second pins. We start at 2. So now we need to put the bits 2, but on the outputs now. The bits 2. Did we use the inputs 2 also? I think we used inputs 2. They correspond. Look at these. Now we're going to the bits 2. All right, it's fine. Connect, and we're gonna go to bits, and we're gonna go to the bits 2. These are our bits 2. We're gonna go to bits 2 for the outputs now. Where are your outputs? Outputs are 8 bits 20. This is your output. Then you say control, and you click on the white rows there. Okay, you go until 7. You go till 7. Right. All right. And then you then put them like that. From the first one, you can see that even if you put this dashed one, it will assign them. So now we have assigned the output. So now we are sorted. Always click apply, otherwise those outputs will always disappear. So you click apply, okay? And then from here we've established the communication, and then let's close. Let us close and observe what is really moving. Okay, let's observe what is really moving. Place items like this, and then after that, and come now to the first here, this one, and then this one. Make it a true. Make it a true. You wanna say F7. Okay, so this is true F7. This is true F7. This is true F7. This is true F7. You see, so far nothing is happening. And then this is true F7. Okay, I don't think we have a suitable. I don't think we are winning. Ciros visual. Okay, that all right is fine. All right, I don't think there is a response. My use parent. Look at these. This is wrong. Yo, I see now. This is wrong. It must be on enabled. Yes, enabled always. And then you now log in again. Yes. All right. It must be like this. Number one. So there was something wrong there. So now we start again. Prepared value. Maybe just do the first four. You won't tell what is the first four. Let's do the first three. From 0 the first three, then press F7. Nothing is happening this side. Let's zoom thoroughly so that you can see something happen. Then let's click on them. How do they do this? Click on. I'll just go to escape. Okay, and then make the fourth one now to be true. F7. 2.4 output. This we are still not establishing a good communication. This side is still saying, okay, let's see, stop and start. Yeah, this is what's supposed to have happened. So now we have Q4. We are having Q4. The Q4 now, you see, the first three we still don't know them. We know Q4 now. You see, so we're going to say, for instance, we're going to do this. Let's repeat this 4 times. Copy, okay, paste, paste, paste. Actually 5 times, not 4 times. Yeah, and then this is your zero. Let's say it's still not established, and then one, and then two, and then three, and then four. Four is your cylinder advance. Cylinder, cylinder advance. You need to understand what type of a cylinder is it. If it's a single acting cylinder, when you turn it off, it's going to retract. Switch off the cylinder, come this side, turn off the cylinder, and F7. The cylinder will turn off and retract. This is a case of a single acting cylinder. Right. Then now going forward, we want to restart the whole process. We now know our cylinder. Let's now start from Q0 now. Let's start Q0 alone, preferably Q0 and then F7. Q0 indeed goes forward. So now this pushes out and then it goes forward. These, by the look of things, this is what you can do. What else can you do here on these inputs? To my thinking, nothing else except these two outputs. So the Q0 is the output for 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 the cylinder. This one, CB2, cylinder moves forward. These other ones, we can just say NA. They are unapplicable. They don't serve any purpose. In short, it's not a crime not to serve any purpose in the community. And they go until 7. Write them all so that this is more like a spare. They are spare. Oops. Right, until 7. Okay. 3, 4, and 5. The last one should be 6. Right, and then okay, 5 and 6. These ones they don't mean anything. So this is cylinder advance or CA here. CA, not CE. Cylinder advance. I thought it would say extend, but extend and advance is the same thing. So this this is actual the output here. So you must just that lettering is going to have a problem. No letters must be the same. So let that one say cylinder advance. This one, let's say cylinder extend. 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 Right. This one is 5. This one is 6. right, all 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 right. Uh, what is wrong here? Nothing is wrong. Maybe this. Make it C6. Actually, because of their output, make it Q6. Then this one, make it Q5. Q5. In other instances, you might change everything to be like this, but I don't have a problem. I think it's still fine like this. Uh, Q3. You will choose the style you want to use. It's everything you do is just for purpose of order. Q1. Okay, or you can even leave them as Q1 until 6. It honestly doesn't matter. All right, you will do the same procedure now, but for the pick and place. I will have to do a separate video for pick and place, and then when you have this, let's see if we can start and stop the program. When you have this, you can save them. They're very important. These are very important. You don't dare make a mistake not to save them. You have to say distribution config. These are your configuration, right? Put it under Codesys and okay, just put it under your work actually that you must submit, right? And then copy it, and we're going to use it for somewhere. We're going to use it somewhere. Log out, yes, and click on program, and we have the VAR, enter and paste. We have all our configurations there. So now, how do you know if this really works? You must have your start button. Uh, we can just write a simple program that will take out this product and take it there. Let's see. Let's quickly do that now. So go to okay. Last time I had a very big problem. This was gone and I couldn't bring it. So this is how you're gonna bring it under tools, view, yeah, and then toolbox. Then the tool will come. All right. And then now let's go to this. This is for your start. There's no need to always write. And then this is for your stop and for your for start stop. And then when you extend, some people expect this to retract eventually. I don't recommend that. Don't stop it right now. You'll stop it later, and then go to your output. And then after that, put this. And then now we have our P0, enter. We have our P1, enter, and we have our CB, enter, and we have our CB here, enter. Nope, we don't use this conveyor belt first. We need to extend. We need to extend CE, extend first. Okay, and let me show you what will happen if we then say, but it needs to stop and go back as soon as it retracts. So let's do this. So we're going to use this input here, CBG2, which is a cylinder advanced, which is CA. So it's a normally open, and we're gonna say normally open, and then CA, all right. And then now we're going to download this program to the PLC and make observations. Let's then make observations. What's happening here? Right. Oh, we need to. Okay, this is becoming a little bit tricky. All right, because we need to see like that. Number one. So are we? All right. So it goes and place it nicely. CA. Really? Oh, this is good. I thought it was gonna return. It usually returns. Then if it does it perfectly, number one, God is great. So when it's like this, when the product is there, what do we expect? We expect this sensor to then activate the PLC, right? So we expect this sensor to log out. So don't forget to there's a start button there that you must always make sure that is always properly made there. Okay, so I made a mistake here. Actually, let's move this thing up. We can't move. Can we move? We can't move. Can we can't cut? I made a mistake. I should have added first these things before. I made a huge mistake. Can I move the whole thing? Can I cut it out? Yes, like this. Paste. Yes. Then you come here and then you start to add. Yeah, perfect. Like this, like this, like this. Then after that, you then come here and you then say, for instance, uh, when CA is active, we don't really work with CA, we work with the other input. So when that other input, let's input is active, or we are, let me just switch off here and switch on again, cancel and switch on again and load items. So now when this input, which is this sensor 2, when you look at it here, was your point B, this is your point B. All right, when it's active, always include the emergency stop button. When it's active, it must go forward. hmm And then it must go forward to that point C there. What's your point C? So it's gonna go and stop at point C. I forgot to mention something. Point C, let's do here. Point C. This is point C. It's true. You see that? Point C is true. It's a normally closed. So I should have written normally closed here. Oh, sorry. You don't write normally closed like that. You write it like this. Perfect. So it's a normally closed. Therefore, you present it by a normally open figure. Then after that, you have your output. Your output like this, and then you then have to do this as a loop. So this is your cylinder at B, BP, like this. This is a problem. Oh, it's not a problem. Yeah, like this. And then we have your P1, right? And you have your point C, PC, and we have your conveyor now, CB, and we have your CB as a loop. Right, then now we program this, we load this program, and we observe what will happen, right? Right, let's then, ta, and then it goes and then it goes and stop there. So this is a basic program. So this is how we configure one station. And on the next video, I'm going to show you how to configure the second station. So the video ends here to avoid it being so long and very tedious. Thank you for now.